midnight here in Europe, Switzerland. Almost midnight. 2 hours.
Nice. Let's see. All right, let's begin. So today we're going to be talking about hierarchical agent swarms, which is the future of agents. Um, so the primary reason why agents were created at all is to help people automate business operations. Um, so today in this workshop, we're going to be presenting how hierarchical agent swarms can help automate uh, business operations. Okay. And so, uh, yeah, let's get started. So we're briefly going to mention, um, we're going to showcase exactly how they function. Like what exactly is a hierarchical agent swarm? And this is kind of like the general architecture. So a boss, you have a boss that will essentially plan its main, a boss's main priority is to protect the team. The boss's main priority is to plan ahead and discover potential failures and also delegate tasks. So it's kind of like if you want to like, it's like imagine if we took the structure of communication between humans, like with humans, we have companies, we have governments. And within these governments, there are leaders, there are directors, there are bosses, there are CEOs, there are chairmen, and then there are presidents. These people are responsible for planning. These people are responsible for um, task delegation, delegating tasks to people to work together and communicate. And so hierarchical agent swarms are basically just simulating that, the human organizational structure with agents. So it's the exact same thing. You have a boss that will make a plan, and then you say, give it a task. You say, like, I want to automate I want to create a social media campaign to promote a swarm workshop, for example. Um, what's going to happen is it's going to plan, and then it's going to essentially delegate. Um, it's going to delegate tasks to each agent. So each agent, like in this case, it's going to be like social media. So we'll have like Twitter or LinkedIn, um, and then those agents will create posts, and then those agents will post that. And that's essentially one of the first examples of a hierarchical agent swarm. Now, hierarchical agent swarms are gonna, I believe in without a doubt that they might be the most used swarm architecture. So in swarms, there's in swarm theory, there are many different types of architectures that require different types of communication. So each swarm, like this is hierarchical. There's also parallel. There's also sequential. There's mixture of agents, and there's entirely new configurations that are completely unexplored. But hierarchical, I think, is going to be one of the most used because it's something that we see every day in the human experience. Again, because every company, every organization, and probably every human institution is hierarchical in a way. And we'll get into more of that later. But basically, how it works is you have a boss that is going to make a plan. Then the boss can create the agents from scratch. So I'm going to show you the code in a little bit. But like the boss can plan, and then the boss can create the agents, or you can make the agents and give it to the boss. And there's two options. So what's going to happen is at a very low level, the way that this works is the boss is making a plan, and then it's going to make a function call to essentially create each agent. So if we go over the code now, I'll show you what the spec looks like. So in this example, we're going to have the boss creates. We're going to have the boss create the agents. So here we have a context window, and here we have a spec. It's called agent spec. And within the spec, we have a couple of settings. So we have a name for the agent, we have a system prompt, we have a description, which is mostly just for the boss. We have max tokens, temperature, and context window, and we could probably trim these settings out. I don't think they make much sense. We could probably just have the name, prompt, description, and tasks. So we could probably work on that in the future. And so that this is just one agent. The next spec here has multiple agents. So we have a name. We have the name of the swarm, which is marketing swarm, finance swarm, or whatever, whatever the boss or whatever you say. If you wanted a programming swarm and you say, I want you to create the code for a Python game, or for I want you to create the code to send swarms of OpenAI API requests. You could, if you say that, it'll build that swarm. And then we're going to have a list. So then the boss is going to make a list of multiple agents that takes in this spec. So it's going to make a list or multiple agents with this spec. And then we have rules for each. We have rules for each agent. We have a common set of rules that each agent is going to follow. So in hierarchical swarm, basically, to summarize, we have boss or director. Now, in some cases, we can have like sub bosses, like a management team. For example, we have a management team. We can have like a chief of staff that then works with all the like executives. Basically, if we search like an organizational structure of a company, you could basically replicate this. You could basically replicate like a whole company with a bunch of agents. Basically, you have a president, you have a vice president, you have creative services, accounting, marketing, whatever. However you architect it is basically how it works. So it's very flexible system, but again, the main theory here is that there's a boss. The boss sends tasks to a certain series of workers, and then those workers will do things. And there's a lot of potential in the future for configuring this. So right now, the way that you interact with it, that you interact with the hierarchical swarm, is you basically give it a very you essentially give it like a command saying, I want you to create a swarm. Let me know if you can see this good. Create a swarm of agents for a marketing campaign to promote the swarm's workshop. Then we find the name of the workshop, which is get the specific name, and then we say create agents for Twitter, LinkedIn, and we could also do email. So emails. What else? Twitter, LinkedIn, Facebook. It's kind of weird because I don't think I know someone that uses Facebook anymore. It might just be like a dead app or something. So yeah, that's basically how you interact with it. That's what you say. You say create a swarm of agents for a marketing campaign to promote whatever it is. So it's going to create like multiple agents, and then those agents will then be specialized for these activities. But I'll get into that example later. I just for now I want you to understand exactly like what exactly how does this look like, because people are already like confused about what an agent is and exactly what they do. Here, when we're talking about an agent, in theory, this could be any form of AI. I mean, it could even be a human being. So an agent is just something that has at the most abstract level, an agent is a form of intelligence that has a goal. Basically, that is the most abstract definition we can go. Agents can be humans. Agents could be like bosses. Agents could be AI. Agents could be humans. Basically anything. So, like I said, most companies and organizations and most human institutions are hierarchical. Um, Again, like the picture I showed, the like here we have um, like if we go to a U.S. government organizational chart, um, there is a boss, or U.S. government. Uh, yeah, let's see. Yeah, you see, like there is a very there is a set defined um, hierarchical. We have the president, then we have the Supreme Court, um, and then uh, we have the Supreme Court, then we have the Senate, then we have Congress. I mean, even China's government is also hierarchical. Xi Jinping is still the president of communist China, and so there is still hierarchy inside of communist societies, um, which is very very interesting because um, the whole premise of communism is that everybody is equal in some way, like very very abstractly. So even in the human organizations that try not to be hierarchical in nature, which is kind of the point of communism, then I mean there's still a very very clear um, hierarchy. So yeah, there's that. um, yeah, so like examples are like an example of hierarchical swarms in real life are companies, managements. You have middle management, and then you have like the working base of a company, which is kind of like the engineers or salespeople, or like kind of like all the low level workers, you would say. Mostly engineers, though, in our case. Um, so yeah, basically, like I said, I'd say probably 95% of gathering, like social gatherings, any gathering of two or more people might be hierarchical. Um, that's just the way we've evolved, I guess. So now let's get into some use cases. One of the first use cases that come to mind is essentially creating like a marketing team. So the way that this works in practice is in real life, you have a marketing team. You have a leader of a marketing team who's responsible for making a plan. So this plan is going to help the leader of the marketing team to essentially, think through what exactly needs to be done. So the team leader is going to first make a plan. Then that plan is going to involve the workers, and then the boss is going to send tasks to the workers to generate tweets or LinkedIn posts or any form of content that you specify. If you say, I want agents for TikTok, I want agents for this, it'll make those agents. And so we're going to run into an example now. And so the way that you can add a plan basically is you just go to the spec here, and then you say, and basically you just put a plan. So we're going to go here. We're going to say we're going to log the name so you can see the name. Does anybody have any questions? Okay, so we're going to run this. I say, create a swarm of agents for marketing campaign to promote the Swarms workshop, and create agents for Twitter, LinkedIn, emails, Facebook, Instagram. Yeah. TikTok, it's not that easy because we can't make videos autonomously yet. So we're going to have to leave that out. So the boss says, look at that. Would you look at that? So here we say, uh, the boss created a swarm name called Marketing Campaign Swarm for Workshop Promotion. Plan. Execute a coordinated marketing campaign across Twitter, LinkedIn, email, Facebook, Instagram to promote the workshop, automating business operations with hierarchical agent swarm. Each agent will create and manage platform-specific content and interactions. And then it creates the agents. So here we have 5 agents. We have a Twitter agent, which handles Twitter marketing tasks. We have a LinkedIn agent, which handles LinkedIn marketing tasks. We have an email agent, Facebook agent, Instagram agent, basically exactly what it said in the plan. And then now it's going to create all of those tweets. And from the look of it, the Twitter one made a lot of tweets. So let's see what we have. We have an agent workspace here that all the outputs are going to be logged to, and we can see the post as well. Like what we could see, it creates a file for every post. So here, the LinkedIn agent. Let's see, is this finished? Okay, yeah, it's finished. So here, the LinkedIn agent said, exciting news for business leaders. Are you ready to revolutionize your business operations? Join us for our upcoming workshop, Automating Business Operations with Hierarchical Agent Swarms. In this hands-on session, you will learn how to leverage cutting-edge technology to streamline process, enhance productivity, and drive innovation within your organization. And yeah, so it made a series. I actually made 4 different posts for LinkedIn. And if we go down now, let's see, tweet. Let's see what Twitter said. Ready to revolutionize your business operations. Join our workshop on automating business operations with hierarchical agent swarms. Learn how to streamline processes and boost efficiency like never before. And then just, simple date. I didn't tell it a date, so I just made up these placeholders. If we wanted to do this again, I'll show you. Maybe it'll be much better if we give it like a very specific time and date. So we're going to take the time and date of today's workshop, and then we're going to pass it in. So Saturday, August 17th, let's go ahead and put that there. The date is, boom. And now we're going to run this again. And yeah, let's see what happens. So this alone right here, I honestly think that as marketing becomes more fierce and aggressive, the need to iterate in real time is going to be obscenely high. Because if you're not iterating in real time, your message, the message that you're trying to communicate to your customers is going to be severely limited. You need to take in information, iterate on that information, and then redistribute it to your users as quickly as possible. So here we have the second set of tweets and stuffs, and the tweets are really good. Let's see, ready to revolutionize your business operations? Join us August 17th from 4 to 5 for our workshop, Automating Business Operations with Hierarchical Agent Swarms. Now, if we wanted to optimize this, we would just simply delete all of these metrics there. So we're going to delete this stuff because not really necessary at the moment. It's a little bit too specific, and that can be a little problem for us. So now we deleted that. Now we tried again. We should have better prompts. We should have much better agents, because agents have a set defined number of outputs. So if those outputs, for example, in this function call, they were being allocated to temperature. They're being allocated to things that were simply not important for our use case. Let's see. Oh, yeah, we have a problem. Well, we're going to fix that problem right now. And we'll just cut that off, and then we should run it again. So another very important thing in agents is that the need to essentially iterate on your prompts, and the need to iterate on like the the interactions between each agent is very high. Like you just saw me, I just found a way to improve the performance of the swarm by eliminating unnecessary inputs. And then boom, hopefully now our outputs would be much better. So we have a swarm name. A marketing team for workshop promotion, execute a coordinated marketing campaign across multiple social media platforms, an email to promote the workshop on automating business operations with hierarchical agent swarms, scheduled for Saturday, August 17th, 4 to 5 p.m. And then there's that. Let's see. Let's see some of these outputs. If we go to our agent workspace here, we can find some of these outputs. Twitter marketing agent. No, these are all. Oh, we could just keep looking here. Sure, here's some agent. Okay, so this seems to be hallucination. Um, Hallucinations do happen. For example, this temperature is quite high. We should probably make it a little bit lower and make the prompt better. So we're just going to try one more time. And after that time, we are going to try to build some code. And we'll try to use this for engineering stuff. So I'm going to run this. Big bada boom, bada beam, bada boom. Let's see. Still hallucinating. Still hallucinating. Why? Why are you hallucinating? Why? Why? I think I know why. So we're going to take this. Then we're going to. And that should fix it. Debugging agents is probably going to be huge. We need to find ways of how can we detect hallucination? How can we detect missing prompts? This is probably going to be a very, very big problem for people to solve. Because if you haven't had the experience of building, thousands of agents, um, it's very, very hard to build good agents. So, okay, it's working. Unlock efficiency, join our workshop on automating business operations. Are you ready to revolutionize your business operations? We're excited to invite you to our upcoming workshop, Automating Business Operations with Hierarchical Agent Swarms. And then we have the Instagram one, Unlock the Future of Business, join our workshop on automating business operations with hierarchical agent swarms. And yeah. So now the next big use case is engineering. So right now, the way that most engineering teams function is we have a lead developer of some kind. Then this lead developer is working with junior developers of some kind. I don't mean like junior developers. I just mean that they are essentially like a worker agent. So lead developers will most often create a team of engineers for a task. This could be to create a website. This could be to create a database backend. It could be for data engineering. Um, any like engineering task is basically going to operate in this hierarchical structure. So what we see here is that we have a lead developer, right, who is going to assign tasks to workers. The workers are going to submit code to the boss. The boss is then going to rate the code, and the boss is then going to rate the code. And then is the code good? Does it work? Okay, yes. That's basically how most engineering teams function. Now, with the God-given gift of AIs and LLMs, we could essentially automate this entire process. Um, at scale. So lead and especially as agents get more and more better, like individually for agent execution and the ability to create really good code and execute that code agentically. I honestly think that like pretty soon there's going to be like millions of agents working in like kind of like AI like kind of like an AI engineering team. And I think every company on the planet is going to have like an AI engineering team that is like super effective, super operationally competent. You basically say, I want to build an entire website, or like I want a website that has 2 pages and basically shows off our GitHub framework. That's the only thing you say, and then you'll literally get what you want, exactly how you want it. That 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 is the ideal outcome. People, if you want to build good agents, you have to start with the outcome. What is it that you want, and then once you know that, then you can reverse engineer the whole process. For example, if you want agents to write really good Swift code to make an iOS app, then you would have to specialize those agents for Swift. But you don't start building the agents first without knowing what the goal is. You have to first start with the goal and then reverse engineer from there. And that's essentially how you build really good agents. So basically, yeah, let's actually try to run an example here. Um, okay. Does anybody have any ideas? I'd love to get some ideas.
It'd be interesting if you could try to see if it would generate an API request to any of the social providers to like actually create a post.
Like, can you go deeper?
Yeah, so LinkedIn has an API to create like a post. You might just be able to ask it to try to do that, and or at least like give you the call, and then you can like drop your credentials and or call it like add it to your environment variables and then go from. But because like these all of these models know exactly what the API is, and there's so much code with like interacting with APIs already. You could already have it.
Let's see.
And if you want to understand how misinformation created or synthetic social media posts, here's one line of code. Obviously, don't.
Okay. Um,
Did
hmm.
that just give you a single result back, like as if it prompted?
No, this created 3 agents. Each agent needs to generate. code for a specific platform. They must return the Python code only. So there, it was basically just making documentation. So that's where the quality of the prompt comes in, which to do this, we would need to iterate a couple of times. So that worked. So here where you see the plan. Create a swarm of agents where each agent generates Python code to send a message via a specific social media's platform API. The code should be clean, well typed, and focused on using appropriate libraries for each platform. So I made 4 agents. Twitter agent generates Python code for sending messages via Twitter's API, Facebook API, Instagram, LinkedIn. And then we have the code. So to send a message via Twitter's API, you can use the Tweepy library. Tweepy. That's a weird name. Once you have Tweepy installed, you use the following Python code to send a direct message. Just like getting all the environment variables for this stuff like this, like API keys, would take a long time. I mean,
You could also
like
have it generate the environment variable document, but then you have to go fill out all your OAuth. Yeah.
yeah. So maybe
You
then you
can't
can
get
make
around that
agent
though.
teams. What was that?
So if you're someone who's already doing this on the regular, you're already gonna have a lot of that set up. At least you're gonna have your, whether it's in your notes, some text file, or environment variables, you'll have your creds or some sort of authentication scheme for interacting with to these APIs. So this is a generic task decomposition.
Yeah.
Hey, can I ask a question regarding Swarm?
Yeah. What's up?
I really like this feature where it can, automatically figure out, APIs and everything. I wanted to ask if there's any first-party method for direct, like where we can automatically and safely execute the code that is written by these agents.
Say it again. Do you want to
Is
execute
there any
code?
way to yes, I want to execute code that is written by these agents.
Like in an environment?
Yes, in a safe environment, exactly.
I mean, you can do that with swarms. Like we have a function that would allow you just to like execute the code. Um, and but basically that'll still be like that'll still be like inside of a small virtual environment. So it potentially like maybe it will like if you say delete every file on this computer and it actually executes the code, it probably will still work. The only way to do that safely is maybe through having like an API to AWS where you can have like an EC2 instance or some form of compute that is not in your environment. So
Yes, I was interested in trying to use these to set up different EC2s. Like doing maintenance on an Ubuntu computer, getting it up and running, and that kind of stuff. So, I was interested in seeing how easily I could, maybe give it an SSH tool.
yeah, like using SSH to connect to the but you could automate all of that away. So when you're making tools for agents, the only thing that the agent should be outputting in the function call should be the code that gets executed inside of the API. So
Mm-hmm.
if you gave it an SSH tool, it most likely like it wouldn't have as much tokens allocated to the actual code that you want to generate. So if you automate that process, if you just connect it, the only thing it should be outputting, it should be focusing its attention on the code. Does that make sense?
Okay, that makes sense. The Can I ask one more question? So sorry for holding it up.
No, no, no. Of course. Yeah, we encourage questions.
What is your recommended method for running swarms continuously? Like if I wanted a scenario where something that can be triggered every minute, and I want a bunch of swarms to act on it, how would I go about building that kind of a system?
Um, like each agent is like constantly communicating with each other, or like I'm like, can you
Each
go deeper?
agent, I want each agent to be I want each agent to be triggered upon, say an API request or, some third party webhook or something. I
Yeah.
basically want to, have it run when there is new data to run for. Does that make sense?
Yeah. So for that, I would recommend using an API. So like so you would create the agent code, and then you would wrap the agent in an API. And so with the API, then once you have a new instance or a cron job, like you said, like it would send a request to the agent API, and then you would get a response. And that way, the agent will only work when there's things to work on. And like if an agent's going to be working on things that it's not supposed to be doing, that's going to lead to more costs. It's going to lead to more energy consumption. It should only like an agent should only do a task that it's designed to do, if that makes sense. So
Absolutely.
so for that,
Absolutely.
you would so if you want a more specific answer, I would say create the code for the agents and then wrap it up using Fast API and essentially create a Python, create a API around the agent, and then, like I said, once you have something for the agent to do, then you just send an API request to the agent, and that's basically it.
Absolutely. And how would you have it, and what would be your preferred method of having it remember what it ran last time?
So so in Swarms we have a looping system. So if in an agent, if you go to the front page of our GitHub, just look up Swarm's GitHub, and on the front page of the GitHub, you'll see that we have a metric, a parameter called max loops. In this parameter, you can define a certain number of loops that you want the agent to basically loop in to get the task done. And so that might be a potential solution.
I'm sorry, I was asking about it being able to work with like, some sort of like a vector database because I also wanted to be able to, remember what it did before I run it once again.
Oh, okay. So I mean, yes, if you have a lot of text, so if you have a lot of like a lot of text, like hundreds of thousands of tokens,
Yes,
then you would use RAG. Um, if it's not that much, maybe let's say one Python file or something, then you could just directly embed that into the context window of the agents. There's no need for RAG.
I'm sorry, what is that word that you're using?
Context window?
Oh, no, before that.
RAG?
Oh, yes. Oh, you're saying as in recurrent access generation. Okay.
Yeah. So I would
Okay.
only
So,
I would only use the.
Swarm supports RAG.
It's retrieval augmented generation.
Sorry,
Uh,
yeah. Does it support that?
yes, yes, we do. Here, check it out. So you could add, ChromaDB. Um, you could add
Okay.
Chroma. You can
Okay.
add.
Okay. It works with ChromaDB.
Yeah. So you define your ChromaDB instance, um, which you basically just say what metric, how many results you want it to return, the name of the folder, and then you just plug it in one line of code, and then now your agent has basically infinite memory.
Damn, that's pretty cool. That's pretty cool.
Yeah. Thanks. Yeah. So you just, you give it a name, you say API memory system, and then it'll basically like it'll every time you give it something to do, it'll first query the database to make sure that it's already there. So you won't be actually like wasting money sending like you won't be wasting money sending OpenAI money for like tokens you already made. Does that make sense?
Yes, yes, that's exactly what I was looking for.
Yeah, cool. So yeah, just check out the Swarm's GitHub, the front page, and there should be an example for you to there follow. If you can't figure it out as quickly as you'd like, you could just hit me up or anybody on the team, and we'll be there for you.
Thank you so much. That's amazing. I'm so grateful for you guys and Swarms.
Thank you, brother. That makes me very happy. It's nice to hear that. Yeah. So does anybody have any other questions? Any other swarms they like to see?
Well, actually, if you can elaborate on how exactly memory works, that would be appreciated. Like, I know that vector databases are basically like usual databases with text, but they store text in a special format that is lossy, right? Basically, they store embeddings, but you can kind of think about it like they're just storing text.
Well, the only thing, so let me demonstrate this. So you send a task to an agent, right? Instead of it being this,
To
what?
send into it, right?
Yeah. So you send task to agent. Before agent receives the task, it's gonna go to the vector database. If answer exists, it's going to go back. If no, then it's going to go to the agent, um, and then the agent will send something back to you, and also put that inside of the vector database. So this is essentially how memory works.
Agent only get one input. So like when I go to ChatGPT, I can send it multiple messages and it remembers all of them. But here agents only get one message as an input, right? And they
Well,
always
so what the way that the way that ChatGPT works is, well, first anything coming in and out is going to be sent to the database, even if it even if it is using a vector database, which we don't really know. We know OpenAI assistants are using memory systems, but we don't know if ChatGPT this, like this ChatGPT is using a vector database. That could be the case. That could not be the case. But the way that most memory systems work, including OpenAI assistants, is basically this. Anything coming in and out the database, in and out the agent, is going to be put inside of the vector database, which is RAG, or long-term memory. It has a bunch of words. Um, so there's basically, yeah, anything coming in and out is going to be put here, so that if there's an answer that exists, the agent is not wasting tokens generating things that it has already made, which would cost you a lot of money. So it basically anything coming in and out is sent to the database, so the agent remembers everything. Does that make sense?
little. So agent can your agents support like a dialogue, a chat with multiple messages? Like I ask
Yes.
something, then I get an answer, and I ask some more. If we have a dialogue with 4 messages, what exactly is stored in the memory?
Everything. The whole thing. Everything you said,
So
everything it
the whole
said.
history of dialogue. And it also stores like when I first send the message, then the reply, and when I send the second message. So it will store
Everything.
one record with the first message and the other record with first two messages, right?
Yes, you send message. Message
Um,
gets sent to database. Agent makes message. Agent message gets sent to database. You say something back. Database. Agent says something, goes to database. Anything coming in and out
But
I just
is sent to the database. If you use RAG,
I
that
just
is.
want to clarify one more thing. It's that might I know you're trying to explain everything simply, but I think one concept that if you help explain more would be helpful for everybody to understand is the concept of chunking. Before your messages and your data goes into a vector database, it needs to be split into a particular size of chunks, a predetermined size. And so that is how it might be split up. So if your message is actually bigger than the chunk size would allow, that would then be split up into two chunks and then stored as two different records.
So the chunking. So let's say if you have a really long document, let's say you're trying to embed an entire book, right? Embedding models, which are there are models that just embed things, which are the embeddings that vector databases use. What is essentially happening is every time you embed something, let's say ChromaDB, there is a model that ChromaDB has to use to embed the documents. Now, within this model is a context window. All models have context windows, all of them, every single one. There is a limit to how many inputs it can get and how many outputs it can generate, unfortunately. So basically, how that works is the context. When you're taking a document, let's say you have 100,000 words in a document, and let's say the model's the model's context window is 1,000 words. You would basically have to for every single you would have to split up the document into 1,000 tokens. Basically, just divide the number of tokens and the number of potential things to embed by the context window of the model that is doing the embedding. And then once you do that, you just basically do that in a loop for every chunk. And then now all that is in the vector database. Does that make sense?
It's also important to uh, just quickly mention that uh, vector databases do have collections documents, but if you're querying an individual document, that's a similarity search. And it's pretty much just doing a direct word for word comparison versus like semantic search that's like has some sort of metadata or index. It's different.
So let's see if we can find ChromaDB architecture. You should really look this up if you're interested in this RAG stuff. ChromaDB is by far the simplest RAG vector database long-term memory system that there is. But if you use ChromaDB, you don't even have to worry about the chunking. It does all that for you on the back end. This is the diagram that I was showing you. So your query is the first thing that happens when you send if you're sending a request to a model that is using a RAG, the first thing that's going to happen is it's going to get sent inside of the database, and then the database is going to retrieve documents that are related to this, and then these documents are then going to be put into the prompt of the LLM, and then the model is going to say something that hopefully you like, and that's basically that. Does that make sense? Or no, no good. Hello?
Well, yeah, I know that, but in my head it's very hard to understand how can this be useful, because when a document is split in 1,000 chunks, even with overlapping, you still will probably lose a lot of information. Also, do you happen to know when you construct this augmented query?
What do you mean? What do you mean?
As oh, I think I know the answer to my question. I think ChromaDB stores like embeddings and also the original text that came from this embedding. So they probably just put the original text of the document.
Yes, sir. You are absolutely correct.
I don't think you're not. So you're not losing information. I can see why you would think that if there be many chunks. If you wanted to solve that problem, what you could do is you can get a better embedding model with a very long context window. So you can embed many things at once. But that will cost you more energy because now you need to store more embeddings inside of the vector database, and it's going to be more expensive for you to query things. But it doesn't even matter because you're not losing information. You're just segmenting information. So if you say, I want a document from this past quarter's financial results, it's going to bring up the chunks that are related that have any of those words in those chunks. So if there is 5 chunks, let's say financial report last quarter or whatever month, it's going to retrieve those chunks, and then now your agent will remember them. So there is no loss of information.
The amount of information that you get is based on how well the model performed and its training. Generally, the higher number of the parameters, higher performance. You just look at benchmark for amount of information extracted. Do sliding windows, things like that if you're really worried about cycle. But it's really not much of a factor when you're talking about such like small scale individual interaction, which is I think what Kai is trying.
Yeah, there's not really that there's not really information loss in the way that you would expect. I would encourage you just to try and build a system because anything I say, what'll allow you to actually understand a system is by trying to build it and trying to seeing it fail. There's only so many words that can come out of my mouth to explain something. But it's probably not going to help you. You just need to try and build it yourself and see what you learn. You'll get a much better intuitive understanding at that point.
Okay, thank you very much. I will get to it at some point.
Sounds good. I see a lot of people are interested in RAG. Very interested. Um, it's good,
Chat
but
with your data.
what?
Chat with your data.
Yeah,
It's pretty amazing. It's a
yeah.
Yeah,
complicated tool, though. There's a lot to it.
maybe we
Well,
could have another one in the future for that.
yeah, absolutely.
Definitely.
We love to. Yeah, we're actually working on a RAG framework called Swarm's Memory. We're trying to make it the simplest RAG framework ever, but also the most powerful. I just sent the GitHub in the general channel if you want to check it out. So it's also integratable with Llama Index and all the other frameworks. So yeah. All right. So a couple of more examples that we're going to be doing for hierarchical swarms is hiring. So that is looking for people on LinkedIn, GitHub. You essentially be able to create like a like a swarm of agents that will basically find very good people for you to hire. Um, so that could be like searching up someone's GitHub, sending them an email, kind of like that at that point. So each agent team then would be like 3 agents. And then the boss would have many teams of agents. There'd be like 6, 9 agents that are divided into 3 groups. And that's one way that you could do that. For finance, so in finance is very hierarchical. There's, vice executive chairman and like a whole shit ton of titles that I don't even know. But basically, you have analysts, you have principals, you have partners, and you could basically like replicate an entire financial firm just by like basically simulating like the organizational structure. And then another one is support. So you can have a support team, like an entire team of like support agents, like in finance. If you ever been to a bank and you're like a big client or whatever, there'll be like multiple people to help you with whatever. So that's one way. Um, yeah. So now, what's the potential of this? Nicholas, would you like to communicate what you see in the future for hierarchical agent swarms?
Yeah, I could actually I was working on a finance hierarchical agent as well. I could demonstrate. It's still in the building, but that could be interesting. So it's a slightly different implementation at what you've seen with. Are you guys seeing my screen?
Yep. Oh, it just left.
Yeah, it should work now. Okay, so it's a slightly different implementation at what you've done, Kai. We have 2 base models for defining each agent. One for defining the team. The team is a list of agents, and then we have a planner agent, a team builder agent. It's very much the same. We ask the planner to basically plan how he would create agents and assign them tasks for a comprehensive financial analysis of a company quarterly performance, include agents for data collection, financial modeling, and report generation, ensure that there is a manager agent overseeing the analysis. Then it's going to retrieve all the agents from the team builder. So basically what the team builder is doing, it's outputting a list of agent with a name, instructions for each agent, and a task for the agent. And one of the agents is a manager agent, so it's in charge of basically creating a consolidated report that can then be given to anyone else. And so one thing we need to change is we need to pass with the agent task the data. We're going to do this right now. Let's create some.
We should make some tools to like fetch bank transactions from your bank, whatever bank account you use. So then like the agents could like get all your transactions and actually like help you save like a stupendous amount of money on like you know trying to find transactions that you could have not like done to help save money. Um, or like creating like a
Exactly.
fully like a balance sheet every month or something, etc.
You use Plaid. They have APIs to be able to connect with your bank, and then I think there's a couple other options out there now.
Yeah, you do, but they don't support all the banks necessarily.
Yeah.
And not all type of accounts as well. So yeah, could be an interesting use case. It's very
Probably
difficult.
limited international uh, compatibility.
Okay, so here we have our agent planner being initialized, our agents team builder being initialized. So the agent planner is seeing data collection, so we don't need this, financial modeling, report generation. So it doesn't have many agents, but let's see what it does. We have Alex, Jamie, each has a different task. So this is the list of agents, subordinate agents. And one of them is the manager agent. So Alex is the manager. And then each agent is going to process the data and pass its report to Alex. So Alex is the manager. Thank you for your detailed work. Here's a summary of the next step for feedback on the financial analysis process. And then it's going to basically write a summary report. So this was built in literally 10 minutes, something like this. We'll be sharing this code so that you guys can create swarms of agents as well. But yeah, with good prompts, this is definitely a use case that could work very well. What I'm actually wondering about, and I think that could be a good debate to have now, is whether it could be better to define the different subordinate agents and not have them generated. So we define each agent that's working in the hierarchical swarm and their prompts so that we have a very reliable output of what each agent is going to do. What do you guys think?
This is amazing. Um, this is fantastic. Um, the only thing that's really missing here is not even, I don't even think it's the prompt. I just think it's the tools. Like actually getting like real financial data and then giving that to the agents. I think that is like if we could do that and say like imagine we have two tools. One that would allow an agent to fetch transactions from a certain time period, let's say within the last month, and then that'll return a list of transactions. And then another tool that could say like block that transaction from happening again. So in that way, you could have agents that can you have agents that essentially like actually help you save real money. Um, and I don't think we're that far off from that point. I just think we need to make a good function, Python function, to be able to retrieve those results. I don't know how difficult it is to receive an API key from Plaid and use their API, even if there is one for like normal people. Um, but if there is, I think we should probably do that soon so like companies can actually start saving ridiculous amounts of money on things they shouldn't be spending money on.
Kai, on that note, can you also talk about how to create tools for Swarm?
Yeah. So basically, a tool in Swarms is literally just a Python function. So if you look at my screen now, I'll show you. Um, Basically, it's literally just a Python function with types and documentation. So I'm going to say generate a function that uses Plaid's API to receive a list of transactions from a certain time period. Make sure the API is up to date. So this GPT that I made basically will help you make tools. Um, it's basically you just need one function. I put it in the general chat so you guys can use it. Um, and basically, yeah, it literally it's you just need a Python function. Okay, you need a Python function, and then you need to basically put types. So you need, for any variable here, you need to put a type inside of this variable, And then once that's done, then you can take this tool. You can take this tool, and let's see. We go here. We go to Plaid API tool, and we put that there. And we have this function, right? We would have to, obviously make sure that Plaid's API works and whatnot. But then we could take this, we could take the agent. And so remember, we created this function. Then once we have this function, we can just plug it in into the agent. So here we're going to say tools. And then here you would say, you would give it the name of this prompt. And that's basically it. That's how you add a tool. You just need a Python function with documentation. There needs to be doc strings, and then there needs to be types, and that's it. You don't necessarily need to do anything special. It's not like LangChain where you have to like do a whole bunch of stuff. You just need a very simple Python function with types. Does that make sense?
That's yeah, that's amazing. That's ridiculously easy.
Yeah, and it's absolutely, and it's very easy just to have like ChatGPT like generate this stuff. So I mean, if this API code is correct and it does work, we would need a lot of things. We need a client ID, a secret, an EMV. Like it's the thing is though, creating tools is already difficult enough. Our idea was to make creating tools as easy as possible. So here in this function, the only inputs to the tool should be the inputs that you want the agent to put. It shouldn't be like like here. This thing was already here, and the agent is going to fill in this function. So anything that's in the input, the agent is going to make. So the start date, it's going to give you a start date. It's going to give you an end date. It doesn't know an access token, so we're not going to ask it to make an access token. So that's basically how you make a tool in Swarms. And then so this is a list. So you can give like a dozen different tools. You can give like 50 tools, depending on, so the limit of tool usage, the number of tools that a model can use is limited by the context window of the agent. And nobody told me this for a long time. It's very secretive. But basically, depending on how long the context window is of the base LLM they're using, basically means like if you have 10,000 tokens, you can only maybe have 4 or 5 tools. If you have like Gemini has 1 million context windows supposedly, you can have maybe 50 tools. Yeah. What do you think?
Do you want to go into detail on what the doc strings map to for tools?
The doctrines are just to basically educate the agent on what the doctrines are there to educate the agent on what should the output be. Should it be a string? Should it be a list of a string? Should it be like the types is very important, because if there is no types, then the agent doesn't know how to make the function, and the tool use is going to be wrong. So the doc strings are like you have to put doc strings so that the agent knows like this needs to be the input, and this is going to be the output. But thanks to God, you could just automate the entire process if you use GitHub Copilot, or if you use the GPT that I just sent you in the general chat.
Thank you so much for sharing this stuff.
Thank you for being here, man. It truly warms my heart. Iterating on these abstractions has taken us a lot of time. And it's taken us a lot of agents. This has been a very, very painful process of building agent after agent after agent after agent, like literal, like tens of thousands, hundreds of thousands, manually written. Even more, like millions of agents have been built fully autonomously. And like we keep seeing these errors, and we try to fix them as they happen. So it's been a very, very painful iterative process for us. So yeah, so basically what's next for hierarchical agent swarms? I think we're going to be seeing people trying to literally have like entire companies be replicated. So you would have literally an entire company just is run by like agent swarms. Like you have a CEO, you have a COO, you have a CFO. Like we're going to be seeing entirely autonomous companies within the next maybe 1 to 2 years, where like the entire company is literally AI, no humans. Um, which is amazing because if as the owner of a business, you can if you wanted to start a company, you could just have a bunch of agents do everything for you, and now you can build that company. Whereas you couldn't because you didn't have the knowledge to hire engineers. You didn't have the knowledge to, analyze bank statements. You didn't have the knowledge to do like any of the many things that a business does. So um, what we're going to be trying to build hierarchical agent swarms where you have like 200, 500, like, or even 1,000 different agents trying to simulate a company and actually have it take actions in the real world through tools. So, like for a finance agent, it'd be analyzing financial things. If it's a programmer agent, it'll be creating GitHub repos and executing code, and et cetera, et cetera. The thing after that is having director in a form of management structure that would allow the bosses to basically monitor and delegate tasks to thousands of workers or even millions. So let's say now like the U.S. president, the president of the United States he has to work with many people, and then those people have to work with many people, and like just orchestrating all of that with AI is going to be a big problem. Because there's context windows, there's accuracy, minimization. Like context window and accuracy is going to be a big problem for that. And we're going to have to solve that if we want to see million plus agent swarms being managed, like extremely reliably. So yeah, that's the second thing. The third thing is inter-swarm mass communication. So a big limitation about using just one agent, like people ask me all the time, why do you use one agent? And the reason for that is because one agent can only do one thing at a time. That is the biggest reason. One agent cannot do 500 things concurrently. It's not possible. It can only do one thing at a time. It's generating the next token, not the next 50, 1,000 tokens concurrently. So that enabling the agents to talk with like 1,000 other agents at the same time is going to be like very, very important. Very important. It's kind of like a Twitter. Imagine like a Twitter for agents. You have an agent that sends a tweet, then other people see the tweet. But when you use ChatGPT, you and the LLM are having a one-to-one conversation. Like when you say something and the AI is generating a response, you cannot interrupt it because it can only do one thing at a time. So enabling communication between millions of agents or thousands is going to be a very, very, very big problem to solve. And the next one after that is having a boss that can create like super personalized, super reliable agents just by saying, basically giving it like a very simple prompt, like generate a team of AI neural network engineers that know PyTorch or TensorFlow. Like they would have to have really good prompts, really good tools, and just enabling the bosses to do that is going to be is going to be like a very active area of research for us. And it's a pretty considerable problem because if the bosses can generate agents really well, then they're not going to be wasting energy or money. They're not going to be wasting your money because those agents that it makes are specialized to that task that you give it. and you don't have to waste like hours, 5, 10 hours building prompts for 50 agents. The boss is just going to do that reliably. Um, so that's the next thing. And the last thing is like having bosses orchestrate sub swarms within a swarm. So in a team, you have like let's say like a CEO, right? The CEO has a sub swarms beneath him. He has an accounting swarm. He has multiple accounting people working together. Then the CEO also has the marketing people within their own team, and then those marketing people are working together to make marketing stuff. And then the programming team has their own team leader, has their own engineers, and they all need to work together. And so that's going to be another feature that we add in pretty soon.
The incredible thing is they all share the same interface, which is language. And at any point, they could translate to any language, which means localization is essentially whatever your communication model is using for your agent. So this we're talking about universality and open source access.
Yeah,
Part of the
absolutely. There might even in the future there might even be like new forms of like entirely new languages built just for agents and just to enable agents to communicate effectively with like the lowest possible entropy. Using like Shannon's information theory to essentially like try to minimize the energy consumption of sending messages, which has been historically a very big problem for human beings. Um, so that might also be a very very big possibility. Um, and yeah, that basically concludes um, my little talk here. If you have any questions, let me know. If you want to see any demos, let me know. Yeah, that's basically it. Thank you for coming.
I was late to this. Was it recorded? I'm sorry.
Yeah, yep.
Also, I'm interested in, you said the next phase is to create these agents of the company and such. Is there an example that you would be starting from?
Like a code example,
Like
or like
like in the playground, you have a ton of examples there. And is there one that you think is closer to that starting point than the others?
yeah, I have sent this. So I have sent the script that I've been using in the general chat. If you scroll up a little bit, you can actually find the Python file that I've been working on this entire presentation. And all you have to do there is just say, create it in the last part, the last thing. You say, I want to swarm for engineering. I want to swarm for this. And the more explicit you are, the better it'll perform. So yeah, I've already sent the code. And when I publish this code, because I'm making a big update to the repo, then I'll publish the example that I just did. But
So the Python function generator is what you're talking about?
no, I published the full Python code of the entire hierarchical agents form that I was using during this presentation. It should be in a file called. Um, it should
Just in
be
a
like,
message.
yeah.
Yeah.
Oh, there it is, the PDF workshop presentation one? No?
No, um, I
I can
could.
I can add you. No worries. I'll try to.
I apologize for being late, Kai. Sorry.
No, it's okay. Life gets a little bit chaotic
I've
sometimes.
kind of dropped off for, I don't know, got to be a month or two.
Yeah, well, it's nice to see you back. Um,
Yeah.
yeah,
Okay, cool.
we're gonna publish this on YouTube. But the point of a workshop is to be interactive. You know,
Right,
the
right.
team, the Swarms team is here to actively answer any questions, concerns that you might have. That's kind of like the whole purpose of this is to answer people's questions and concerns in real time. Whereas in a video, is kind of like, you know, it's like there's a set amount of information in a video. And you can like directly ask it any questions.
Yeah. And I'm sorry, you pushed the
I'll
attachment. Okay.
I'll just send the code again so you have it.
Oh, I think
Yeah.
I see
So
it here. From Swarms Models OpenAI.
yeah. So I just published the code that I've been using this whole time.
Great.
It's the last message I sent.
Because I'm interested in doing this is an area I'm interested in. Are you going to the Stanford hackathon
Stanford
coming up
Hackathon. One.
September 8th or 9th? I can't remember.
Maybe. Can you send the invite?
Yeah, yeah.
Are you back? Are you
I'm
back in
interested in
Cali?
doing. No, I'm in Utah, and then I'm going to Arkansas. I'm sorry, everybody, um, but uh, but yeah, I'm going to that Stanford thing. It's a really short one. I'm interested in doing something with it's similar to what you're talking about, but just very narrowly scoped,
Yep.
um, dealing with compliance. Um, and yeah, guidance and insight from you would be awesome.
Yeah, of course, man. I'm always here for you. Um,
Okay,
and
I appreciate that, Guy.
I think compliance is I think compliance is a pretty good use case as well. Um,
Yeah, yeah, and then again, it's a small piece, but the idea is my experience dealing in the actual corporate world in a pharma company is compliance isn't about solving the business problem where the business needs to get revenue generated, but how do they do it with compliance? And compliance is expensive and it's hard to coordinate, and they don't necessarily understand the business, and the incentives aren't necessarily aligned. So if you can create a compliance agent that helps solve the business problem, um, I think that
Woo!
would be very useful.
Yeah. Oh man. Right.
So that's what kind of a small use case I'm biting off.
for pharma, for like pharma compliance.
I'm gonna keep it simple with the HR.
Oh,
Um,
HR.
I mean,
Okay.
pharma would be cool too, but the Stanford hackathon is only like a half day, I think. Um,
That's not
so
a
it's
hack.
got to be pretty simple.
That's a hack
But
on a 5K.
what's that?
It's like a hack a 5K, not a hackathon.
Yeah, it's like a 5K, but let's see. I'll put it in the list here. Let's see.
Yeah, send the link for the hackathon. Um,
Let me just put it. I'm going to put it in there right there. Um,
who's throwing this?
it's hosted by Stanford Law School with Llama Index.
Oh, we get to go see Jerry.
I don't know if Jerry's going to be in this one. I think it's what's his Pierre
Oh, yeah.
Duslat Pierre. Yeah.
Yeah.
Who's that saying they know Jerry well?
I don't know Jerry well. I've
Oh,
interacted with him like a couple times.
okay, cool. Yeah, I'm impressed with Llama Index stuff. Um, they 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 got a pretty tight team there. Um,
This form is kind
but
of ridiculous.
what's that?
The form for this hackathon is insane. There's like 100
The
questions.
form?
Yeah.
Yeah, you got to get off the list. But I'm sure if you wanted to go, I'm sure they'd let you come.
Yeah. I'm not gonna fill that up. But just build an agent to do all that stuff.
Well, yeah,
Fuck that shit.
I'm going with a friend of mine. We'd love to have your input. I'm sorry, be on our
How,
team.
how
Heck,
yeah, how about this? You send me the address and the time and I'll just pull up. I'm not gonna sign up to this
yeah,
thing.
it's right in Palo Alto. It's Stanford Law School. Yeah, let's plan. Let's do it, man.
All right, fuck yeah. Let's go.
Sweet.
Look,
Okay.
one of the projects that I did at a hackathon once is I made a very simple swarm where we took all the people's ideas for projects and we literally built them out all using agents. So I think if we could just do that really well this time with a hierarchical agent swarm, we could potentially build every project inside of the hackathon all at once. Every single project. Like it's
Yeah.
unbeatable.
Oh, yeah. I'm kind of.
That is the ultimate hackathon project. The thing is though, you need a CSV file with or like a file with everybody's ideas, um, and like a description of the thing or something. Um,
Well, I'm going to keep it simple into um, my experience working on an enterprise program office and as a strategy consultant working in Fortune 100 companies. So I'm going to keep it simple. Um,
yeah,
of
absolutely.
let's solve let's create these roles and solve some problems.
Yeah, absolutely. Um, or
Okay,
yeah,
cool. Let's touch base more as we prep for this because my experience in hackathons is spend the first 4 hours just figuring out your stack without putting together a team. So I've already taken care of that. And it would be great to have your input. Okay.
yeah, of course. I'll be there.
Sweet. Anybody else?
To the hackathon?
Yeah, there's another really good one coming up in October. Um, what is it? It's the Ragathon. Um,
Oh, we're gonna wreck that.
are you guys going to that in October?
I mean, now
Um,
I will.
yeah. The thing is, though, it's kind of funny
Uh,
showing up to these hackathons because we've gone to so many and we have won so many that it's not even like it's not even a fair it's not even really fair if we use swarms. It's really like we could build any form of agentic system in maybe less than 20 minutes. Anything, any type of agentic system you can imagine. Um,
um,
well, it's really
well,
obscene.
the
It's not
yeah,
fair.
well, right, but you're doing it as swarms, and you're not doing it as. So I'm approaching it as a team that wants to solve the problem using swarms as one of the key tools in solving that problem. You're approaching it as, hey, we're swarms. This is our weekend hobby. We just showed you guys all how to do this. We're next on to our next problem, right? So I'm like, this is kind of where my focus is solving these kinds of problems, and swarms being one of the key tools for the agents, and then the other part is putting together the right types of you know vector stores and knowledge graphs to do that.
Yeah. I just published a financial API Plaid tool inside the agent marketplace. So if you want to like give your agent the ability to like get bank transactions using your Plaid account, you could do that now. Um, we're probably gonna build a bunch of more tools for like financial stuff because like agents can like help you save so much money. It's not even funny if they
Oh
have
yeah,
access to your actual
oh,
bank statements.
yeah,
Um,
yeah. No,
so
yeah, yeah, um, yeah. This is way cool. So let's talk more, Kai. Yeah, how do I get on your calendar?
um,
Just
here,
Calendly?
yeah, no, we use cal.com now because they're open source.
What is it?
Cal.com. It's so much better than
Okay,
Calendly.
cool.
Yeah, they're really good. I just sent you it. So
Yep, got it. Excellent. Well, it's great to talking to you again. Say hi to everyone,
yeah, you too.
and I'll
When will
yeah,
you
I'm
be in
excited.
Cali?
I'm coming back